Hey there, scientists. Please watch the video, take notes as you do so, and answer the questions in OneNote. Once you're finished, upload those to Classroom. Have a great day. Bye-bye. Hey there, F period. This is D period. Say hi, D period.
F period.
Hey, F period. We're going to do the lesson together today. So you're going to hear my lovely voice and you'll see my screen recording up on the screen. If you guys have any questions, just like normal, regular class, feel free to ask them. So what did we just learn about our oxygen models? What do we know about covalent bonding? What do you guys think? Yeah, so covalent, what does that co mean in covalent? Working together, just like co-workers or co-operation. Co-worker means to work together or share. So in this case, what are we sharing? What are we sharing in this case?
They're sharing valence electrons.
They're sharing electrons. In this case, they're valence electrons, right? They're valence electrons. And that's where our word valent comes in. So sharing valence electrons. I gave you all an example with oxygen. Let's try and bind two different atoms. So let's take a look at our periodic table quick. Here's our periodic table. Let's try and bind two fluorine atoms together. Fluorine is right here in our periodic table. I'll give you all just a couple minutes to bind two fluorine. So I want you to draw and give me the equation for those two fluorines.
Can I do it on a whiteboard and take a picture of it?
All you do in your notes.
Yeah, because my silence I can do it.
Sure, that's fine.
So can you do it with the whiteboard?
Yeah.
Are we doing it like not the Bohr model?
Tim had a really good question. He asked, why is this important? Why do we need to know how electrons share? And the simple answer to that is because in nature, many of our important molecular compounds are made of covalent bonds. In fact, all molecules are covalent bonds. That's by definition what a molecule is. It's two or more atoms that share electrons. One of our favorite and most important covalent molecules is H2O, water. So I want everyone to try and draw water in your notes. Draw how two hydrogens and one oxygen share their valence electrons. Yeah, so let's see what that looks like. Let's first draw our oxygen right in the middle. How many valence electrons does oxygen have? We can look at our periodic table. It's right here, 6. Good. So let's draw those 6. I'm going to draw one here, and then 4 more down here. Our hydrogen has how many valence electrons? Let's look at our periodic table. Hydrogen has 1.
And there's two hydrogens.
And there's 2 of them. So let's draw a hydrogen here, and let's draw a hydrogen here. If I circle those,
Yeah, but hydrogen only has 2 now.
and I circle these, how many valence electrons does oxygen have?
8.
1, 2, 3, 4, 5, 6, 7, 8. How many valence electrons does each hydrogen have?
2.
1, 2, 1, 2. Do we know that our oxygen's happy?
Yeah.
For sure, right? Because it has 8 valence electrons, so it has a full shell. Do we know that our hydrogen's happy?
No.
Why isn't our hydrogen happy?
It's not a full shell.
It's not a full shell?
No.
Does everybody think it's not a full shell? Does anybody think differently?
No, it is a full shell. I'm so stupid. I get it now. It's because it's the first 2.
Let's check.
First 8.
Hydrogen, right?
Yeah.
Hydrogen is atomic number 1. So let's draw a Bohr model quickly for hydrogen. Hydrogen would have 1 proton, it has no neutrons, and then it has 1 valence shell with 1 electron.
If you add it, gives a full valence shell. That's so stupid though.
So just adding 1, so if I add 1 from oxygen, then that would be full valence shell, right? Full valence shell because hydrogen can only hold 2. It only has 1 shell. Remember that the valence shells go 2, 8, 8 for the number of electrons. So is our hydrogen happy looking at our drawing here?
Yes.
Is our oxygen happy?
Yes.
It sure is. Sharing is caring. Let's try some other examples. So let's look at our periodic table. Let's try and bind together 2 nitrogens this time. Let's try 2 nitrogens. Nitrogen is in group 15 right there. So let's bind together 2 nitrogens. I'll give you a couple minutes to do that. So each nitrogen has 5 valence electrons. So let's draw those 5 first. 1, 2, 3, 4, 5. 5 for the red nitrogen. And then 1, 2, 3, 4, 5 for the blue nitrogen. So if I circle all of these, and I circle all of these, how many valence electrons does the red nitrogen have now?
1, 2, 3, 4, 5, 6, 7. Oh, 8. Damn, that's so.
1, 2, 3, 4, 5, 6, 7, 8. How many does the blue have?
1, 2,
The blue also has 8. Good. 1.
Wait, Mr. A, do we have to draw it like in that way? Is that just how you draw it?
You should try and draw it similarly. So blue also has 8. It's not important that you draw it exactly like this, but I want you to draw it in some way that it shows it's sharing. So I just circle both to show sharing, kind of like a Venn diagram, right? We call this, so that nitrogen, each nitrogen is sharing 3. What do you think we call that bond?
honest, I don't know.
That's a triple bond.
Diversity? Huh?
It is very generous. It's a triple bond. And triple bonds are pretty strong. What did we do when we did oxygen? Let's go back. Let's practice with oxygen again. So I'll draw a blue oxygen and a red oxygen. I want you guys to bind them. See if you can remember.
How many valence do they have?
Oxygen has
6.
6 valence electrons. It's in group 16. So each oxygen has 6 valence electrons. So let's draw those. 1, 2, 3, 4, 5, 6 for blue. 1, 2, 3, 4, 5, 6 for red. We'll circle who's sharing what. And each oxygen now has 8 valence electrons because of that sharing. If we called when each nitrogen shares 3 electrons a triple bond, what do you think we call when oxygen shares 2?
A double bond?
Good. A double bond.
If it just shares 1, is it just going to be called a bond?
If it just shares 1, it is not just called a bond. What do you think it is when it just shares 1?
Single bond.
It is a single bond. Can you guys take a guess for me which 2 elements might form a single bond?
Hydrogen.
I heard it. Hydrogen. So let's go ahead and bind those 2 together. Hydrogen has 1 valence electron. So if we bind 2 hydrogens together, they're each going to share 1, and that's going to form a single bond. Are those 2 hydrogens happy?
Yeah.
They are. Remember that hydrogen, the first valence shell, only holds 2, so those hydrogens are happy. Good. When 2 atoms that are the same bind to each other, right? So 2 nitrogens together, 2 oxygens together, 2 hydrogens together. These are all examples of diatoms. What do you think diatoms mean? Or diatomic molecules? 2 atoms. So in nature, oxygen exists as O2. In nature, nitrogen exists as N2. In nature, hydrogen exists as in H2. So to form stable bonds, they just find a buddy, somebody just like themselves, and they share electrons. So the oxygen we're breathing in right now is in diatomic form.
Can oxygen be cold or is that like?
Oxygen you can cool oxygen. It can be cold.
Because if it's like really cold outside and it's in the air.
You could bond with 3 of them.
Nitrogen. Oh, 3 atoms.
Like 3 atoms.
I know what you're talking about. That's fine.
So far we've learned about 2 different types of bonding. We've learned about covalent bonding now, and we've learned about ionic bonding. I want to talk a little bit about what the difference between those 2 are. So I'm going to make a little T-chart. On the left-hand side, I'm going to put ionic bonds. And on the right-hand side, I'll do covalent bonds. Has anybody noticed what types of atoms I've been choosing for covalent bonds from our periodic table? Where have most of them been?
They've been even
Haven't they all been non-metals?
They have all been nonmetals. So covalent bonds are always between 2 or more non-metals. Whereas ionic bonds are always between nonmetals and metals. What is the most obvious difference between ionic bonds and covalent bonds? What do you think, Jake?
Ionic bonds use different atoms and covalent use the same.
That's true. But what about how they deal with their electrons? Which one does what? That's what I was thinking. What do covalent bonds do?
Covalent is the one with fluorine, right?
Covalent was examples like fluorine, hydrogen bonded together. Covalent bonds, they share their electrons. If covalent bonds share their electrons, what do ionic bonds do?
Steel.
They steal electrons. They steal electrons. So by sharing electrons, you don't create a charge. So there's no charge on the atoms for covalent bonds. When you steal electrons, you create a charge. You create a charge. The atom that gains an electron is reduced and becomes negative. The atom that loses an electron is oxidized and becomes positive, right? Here, both atoms don't have any charge. Technically, they can have a partial charge, but we'll talk a little bit more about that later. We call that electronegativity. Electronegativity, and that's just the affinity for electrons by an atom.
What does oxidize mean?
Oxidize means you lose an electron, so you become positive. Ionic bonds are stronger, and covalent bonds are weaker. Ionic bonds are stronger and covalent bonds are weaker. So that means that ionic bonds have a high melting point and a high boiling point, whereas covalent bonds. A couple more things to note about ionic and covalent compounds. Covalent compounds we call molecules. And ionic compounds we call salts. Finally, when you name ionic compounds, what you do is you take the name of the nonmetal. You take the name of the metal and you put that first. Then you take the name of the nonmetal and you add the suffix IDE. For example, if it was lithium and fluorine, what you would do is you would call that lithium fluoride. For molecules, what you do is you take the nonmetal that comes first in the formula. So let's say it was H2O. So we take the nonmetal that comes first, hydrogen, and we add a prefix to that hydrogen. So you add a prefix, the name of the metal, and then you do a prefix, the name of the second nonmetal, and a suffix. The prefixes are the number of elements. So those would be mono for 1, di for 2, tri for 3, tetra for 4, penta for 5, hexa for 6, hepta for 7, octa for 8, nona for 9, and deca for 10. So what would H2O be? We take the name hydrogen and we add our prefix. How many hydrogens do we have? 2. So it would be dihydrogen. How many oxygens? 1. So we add our prefix. Monoxide. We don't need 2 O's, right? Monoxide. Dihydrogen monoxide would be the name for that. All right, so what I'm going to do is I'm going to give you some examples of some elements. You have to tell me how many elements you'll need to bind them, what type of bond, either ionic or covalent, you'll be doing, and then the formula. So our elements are lithium and fluorine, magnesium and chlorine, nitrogen and bromine, hydrogen and chlorine, calcium and sulfur, fluorine and iodine. So go ahead and take a few minutes and try and bind those the best you can. I'll be right back with the answers.
Hello, F-period, and welcome. F-period.
All right. Hi, F-period. We're here with E-period now. We're going to go over those answers. So, we have lithium. What's the first thing we have to do? We have to check where it is on the periodic table. Here's lithium, and here's fluorine. Lithium is a metal. Fluorine is a non-metal. So if we have a metal and a non-metal, it's going to be an ionic bond. So we'll go ahead and we'll draw our lithium. We'll draw our fluorine. And we'll draw the number of valence electrons on each. So 1 for lithium and 7 for fluorine because it's in group 17. Fluorine is going to steal that electron. It's going to be reduced. Lithium is going to give the electron. It's going to be oxidized. And we'll have a formula of Li positive, F negative. There's one of each. For ionic bonds, we don't need our prefixes, so this is just lithium fluoride. Lithium fluoride. Next, magnesium and chloride. Let's go look at our periodic table. Chlorine is here. Magnesium
Group 2.
is here in group 2. Good. So if chlorine is in group 17, it has 1, 2, 3, 4, 5, 6, 7. Magnesium's in group 2. It has 2 valence electrons. Magnesiums are metal. Chlorines are non-metal. Magnesium's going to donate an electron to chlorine. Is chlorine happy?
No. Yes.
Chlorine is happy. Is magnesium happy?
No, it
No.
still has an electron, so that means we have to make another chlorine.
Good. We need another friend. We need another friend to come to the party. Magnesium donates his electron. Magnesium donated 2 electrons. It's being oxidized. Chlorine. Each chlorine gains an electron. It's being reduced. Our formula is MgCl2. Each Mg has a charge. It's losing 2 electrons of +2. Each chlorine has a charge of -1. It's an ionic bond, so we just simply call that magnesium chloride. Let's go over to N and Br. N on our periodic table is here. Br on our periodic table is there. They are both nonmetals. What kind of bond must this be?
This must be a covalent bond.
This must be a covalent bond. Let's start by drawing our Br. Our Br has how many valence?
7.
7. So we'll draw 1, 2, 3, 4, 5, 6, 7 here. Our N has how many valence electrons?
7.
N has 5, is in group 15.
Oh, wait, 5, sorry.
1, 2, 3, 4, 5. So if we share 1 with Br and nitrogen shares 1 back, nope, that's a terrible circle. Let me fix that. We share 1 between N and Br. That Br is happy, but is that N happy?
No.
No, so what do we need to do?
Make another friend to join the party.
Another friend for the party.
Wait, what?
Hi, Jenny Perez.
I don't think you
One more friend. Danny is in this class. F period.
that
No.
Guess who's in the class?
Because they're gonna watch us and they can hear it.
So, we need 3 BRs and 1 N. So our formula is going to look like this. N, Br, 3. No charges because it's covalent. How many nitrogens do we have? We have 1 nitrogen, so we just call it nitrogen. How many BRs do we have? 3. So it's tribromide.
Wait.
Nitrogen tribromide.
Tribal?
That sounds like a commercial, like tribromide.
Nitrogen tribromide.
Well, because all of us would be. Mr. A. Oh, because 3.
Because there's 3 bromides.
That's insane.
Alright, let's move on to the next one. HCl. Let's look at our periodic table. Where's H?
1,
H is up here. Where's Cl?
7.
17. Don't get tricked. Those are both non-metals. Remember, hydrogens are non-metal over in group 1.
Send you to that leaf thing, like where they go to you.
So they are going to share, because they're two nonmetals. The last one was nitrogen tribromide.
Yeah.
So these two are going to share because it's covalent. That's going to be HCl or hydrogen
No.
monochloride. HCl is also known as hydrochloric acid.
Hydrochloric acid.
That's in your stomach. That's stomach acid.
Whoa.
Yes.
Can it make you sick or no?
Too much acid can make you sick, but it's naturally mostly by eating foods. It could be one reason. So typically you take Tums or something when your stomach is upset, and typically what that does is it makes your stomach acid a little less acidic. It's a base to balance it out. Calcium and sulfur. Calcium is here, it's a metal. Sulfur is here, it's a nonmetal.
So we obviously have to do covalent bonding.
Obviously.
Metal, nonmetal, makes it an ionic bond.
Wait,
Metal, nonmetal, ionic bond. How many valence electrons in sulfur? 6. How many in calcium?
2.
2. So we can just go ahead and donate from calcium to sulfur. That would give us a charge, 1 calcium with a charge of positive 2, 1 sulfur with a charge of negative 2. Our name would be calcium sulfide. No prefixes for our ionic bonds. Finally, F and I. Let's look at our periodic table. F is here, I is here. 2 nonmetals. That means it's covalent. Each have 7 valence electrons. So we're just going to share 1 from each. Our formula would be Fi, and our name would be fluorine monoiodide.
And that is it.